Alright, here we are in our last video for expressions before we move on to equations. We're going to be talking about factoring. So our I can statement is I can simplify expressions by factoring. So factoring is taking out the greatest common factor. Or you might remember we call it the GCF from each term. So I'm going to find out what the greatest common factor both of them have is and then kind of take that out. It's kind of like backwards distribution. So the answer to a factoring problem looks like the start of a distributing problem. Okay, so we're going to practice finding greatest common factors first. So my numbers are 4 and 28. I'm going to make a factor tree. So I'm going to think, what numbers multiply to be 4? Start with 1. 1 times 4. Okay. Then I move on to 2. I know that 2 times 2 is 4. Okay. And then there's nothing else. Once I repeat a number on either side, I'm done. So we're going to move to 28. 1 times 28. And then if you're not sure, grab your calculator. Let's try 2. 28 divided by 2 is 14. So 2 times 14 is 28. I'm not sure if 3 is a factor, so I'm going to try dividing by 3. Oh, no, it didn't end in a nice even number, a whole number, so nope. Let's try 28 divided by 4 is 7, so 4 times 7. Okay, I know it's not going to be 5 because it has to end in 5 or 0. Let's try 6. Oh, no, not evenly divisible by 6. Let's try 7. Okay, so 7 times 4, but we already have a combination of 4 and 7, or 7 and 4, so I'm done. So I look at my two lists, and I figure out what is the biggest number that both of them have. The biggest number that they both have is 4. So their greatest common factor is 4. Let's do 5 and 45. So I start by writing 5 and 45. 1 times 5 is 5, and that's it, right? 5 is a prime number. Those are its only factors. So I know that 1 times 45 is 45. It's not even, so it's not divisible by 2. Oh, 3 times 15. Not evenly divisible by 4. And then 5 times 9 is 45. I'm going to tell you that those are the only factors of 45. So I look on both lists, and the biggest number that both of them have is 5. So 5 is the greatest common factor of 5 and 45. So using that to factor out something from an expression is we're first going to find the greatest common factor of both numbers and circle the greatest common factor. So factors of 2 are just 1 and 2. Factors of 6 are 1 and 6. And then 2 times 3. I'm going to circle their greatest common factor, which is 2. and then I underline the other factor that goes with it. So 1 goes with 2, and 3 goes with 2. Okay. So step 3, I'm going to take that greatest common factor out, and then put the remaining terms inside. So when I take a factor of 2 out of 2x, we're left with 1. So 1x plus, when I take a factor of 2 out of 6, I'm left with 3. So x plus 3. Oh, I should have done that down here, but that's okay. So let's do another example with some slightly larger numbers. We're going to find the greatest common factors. So I'm going to make my factor trees. 1 times 21, and then 3 times 7 are going to be the only things. The factors of 42 are 1 and 42. I know it's even, but let's say I'm not sure what it is. I'm going to do 42 divided by 2 is 21. So 2 times 21. Oh, 3 times 14. Let's try 4. Oh, not 4. It's not going to be 5. 6 and 7. Since the next one would be 7, but I already have it listed, I stop there. Okay. Then I'm going to circle the biggest number that both of them have. The biggest number they both have is 21. So I put 21 outside of the parentheses. Then I'm left with 1. And that term had an n, so 1n. And then minus, I'm left with a factor of 2. 2. Or you can just write it as n minus 2. Okay. All right, so you have 9 on the back that you're going to factor. Okay, so go through and make the factor trees. Circle their greatest common factor, underline what's left, and that's it.